Hello everyone, I'm Ananya from G500 and today I'll be talking about our project that is Capagent++. So first, I'll give you a quick introduction of our project. Our Capagent++ takes your simple instructions and turns them into clear professional prompts. It then creates accurate context-aware captions for your images in any style or tone you want. Now let's talk about the main components of the solution and how they communicate with each other. So first, we have four main components working together to caption images and videos efficiently. So first we have the instruction evolving agent that takes input and turns it into detailed professional prompts using tools like Google Lens and RAG for extra context. Next we have the planner agent which acts as the central coordinator deciding which tools to use and ensuring captions are coherent and accurate. And then for videos, we're using the temporal captioning agent, which generates frame by frame captions and then merges them into smooth narratives so that we get a summarized version of the caption. And then finally, we have the domain conditioning agent, which fine tunes the captions to match specific domains, adjusting tone, style, and terminology so that the output aligns perfectly with your intent. For suppose we can make it a medical domain specific caption or education field domain specific caption, things like that. And now let's talk about the underlying data structures. The data structures used in this app are like, first of all, Capagent uses vector embeddings, which actually store visual and semantic features for fast retrieval. And then JSON schemas for keeping the agent messages organized, and tensors, which handle the raw image and video data for the models. Now, coming to the roles in our app, first of all, the users, they are the prompt providers. They are basically the ones who provide the images or videos along with the simple user instructions like, specifying give it in a funny tone or give it in a serious tone or confine the caption to 30 words, things like that. And then we have the system agents, which work on their own to generate and refine captions, while the admins or developers, that is us, we manage the data sets, monitor the performance, and ensure that the outputs match the intended domain. Now let's talk about the technology stack used in the app. First of all, for front end, we used Gradio, and for back end also we have used Gradio. Coming to the AI models, we have used Gemini 2.5 Pro, and then we have used grounding Dino for object detection, and depth anything for depth estimation, and then BART large CNN for summarization of the captions. And the language mainly used in the entire app is Python. And coming to the libraries used, we have OpenCV, PyTorch, Transformers, NumPy, and AutoGen. Now coming to the interfaces, first we have upload interface. So this is where we can upload the images or videos, and we can simply enter the user instruction, the simple instruction that the user want to give. And then we have the mode control panel. So we have two major inputs, that is image and video. So there's a toggle like switch which enables the user to switch between image and video modes. And they can also toggle the web search integration. That is, they can generate the professional instruction using the Google searches and Google Lens searches, or they can simply use just LLM for the professional instruction generation. Then for the result display, we can finally show the agent generated caption and the chain of thought messages went throughout that process. And also we have preloaded sample queries for if you want to quickly test the project. And then coming to the data sets, Capagent++ doesn't really rely on a fixed data set. It uses RAG-based retrieval to bring in domain-specific knowledge on the fly. For testing, we use short open datasets for videos like UCF 101 or ActivityNet. And then for image caption references, we're getting from Coco or Flickr 30K for validation. Now let's look at the input and output screens. So like I've said earlier, there are two types of inputs, that is an image input and a video input. Now coming to the first image, we can see here that I've enabled the image mode. So I'm giving an image as an input, and then I'm giving a simple user instruction. This is the simple instruction that is given by the user himself. And then this is the professional instruction generated. And then you can see here a simple toggle bar which enables web integration. So when I enable web integration, I allow Google and Google Lens searches to influence the professional instruction. And this is the professional instruction generated. And this is the final agent response and the final output of our project, that is the professional caption. And these are the chain of thought messages generated by the agent during the process. And now let's look at the video input. Here I've enabled the video mode and then I'm giving a video as an input. And here I'm giving a simple user instruction. Now there are two ways in which I can generate this final professional caption. That is, I can send the first, that is a simple user instruction directly to generate the professional caption, or I can generate the professional instruction here and then send this professional instruction to generate the professional caption. So in this case, I'm directly sending the simple user instruction to generate the professional caption. And then we can see here the chain of thought messages generated by the agent. This is the workflow of our project and it is actually very simple. So first we begin by giving an input, that is the user's simple caption. And if the type of input is video, keyframe extraction is done. And if the type of input is image, it is directly sent to the next step. So here, first of all, instruction refinement is done to improve the user prompt. And then caption generation planner is used, that is the agent. And then we can use domain conditioning, which adjusts the tone or style. And finally, we get the output, that is captioned media plus chain of thought messages. Now let's talk about the business logic of our project. All agents in Capagent++ talk to each other through the LangChain framework, with the planner deciding which tools to use. And captions are defined in a thought action observation loop. And then the domain conditioning is adjust the tone and style after the generation. Now let's look at the demo of our project.